1/1/2 and root 3 over 2. So with that being said, let's try to find the terminal points of some angles that are based off of pi over 6. Let's find the terminal point for t equals 3 pi over 4. 3 pi over 4 is 3/4 of pi. Oh, we just did that, sorry. Let's do 2 pi over 3. Or no, sorry. Let's do 5 pi over 6. To find t equals 5 pi over 6, we go to 5 pi over 6, and we draw our reference triangle. And we see that this angle right here, the reference angle, is going to be pi minus 5 pi over 6, or 6 pi over 6 minus 5 pi over 6, which is pi over 6, or 30 degrees. So this is going to be a 30-degree reference angle. Because we know that's a 30-degree angle, we can now apply what we know. We know that on a 30-degree reference angle, this adjacent side is going to be root 3 over 2. And because it is in the negative x quadrant, it's going to be negative. And then the opposite side is 1/2, which is going to be positive. So we know that the terminal point of 5 pi over 6 is going to be negative root 3 over 2, comma, 1/2. Okay, what if we have to find the terminal point of a reference of an angle such as 4 pi over 3? Let's look at the angle 4 pi over 3 on our unit circle. Do you see that on the unit circle, 4 pi over 3 is right here? So let's go ahead and draw our reference triangle. We need to figure out what this length is and what this length is to figure out what the x and y coordinates of the point 4 pi over 3 are. So first, we need to figure out what our reference angle is. So to find our reference angle, we say 4 pi over 3 minus pi, or 4 pi over 3 minus 3 pi over 3, which is pi over 3. So our reference angle is pi over 3. A lot of you probably don't know yet, but let's convert pi over 3 to degrees so you can have an idea of what that is. Pi over 3 radians, and we compare pi radians to 180 degrees. We cancel pi, we cancel radians. We see that 180 over 3 is 60 degrees. So our reference angle is 60 degrees. So now, using 60 degrees as our reference angle, let's figure out what we have. The side opposite of 60 degrees is root 3 over 2. So this is going to be root 3 over 2. The side adjacent to 60 degrees is 1/2. So this is going to be 1/2 right here. Do you see that this is in the negative x direction and also the negative y direction? So negative 1/2 and negative root 3 over 2 are going to be our two terminal points. Okay, now what we want to do is, what happens if you want to find the terminal point? Lastly, if we want to find the terminal point for t equals 29 pi over 6. Again, remember, the terminal point is while you're rotating around the unit circle, where are you landing? It doesn't matter how many times you rotate around the unit circle. You're worried about where you're landing. So hopefully you can see that 29 pi over 6 is more than one rotation around the unit circle. It's far greater than 2 pi. So a lot of times you kind of have a hard time visualizing where 29 pi over 6 lands. So what you want to do, anytime you have an idea that a rotation is more than 2 pi units around the circle, you want to go ahead and subtract 2 pi over and over and over again until you actually get to a number within 0 to 2 pi. Because when you get to a number within 0 to 2 pi, you have a much better idea of where that is on the unit circle. So first thing we want to do is just take 29 pi over 2, 29 pi over 6, and subtract 2 pi. So that's going to be 29 pi over 6 minus 12 pi over 6. And that's going to be 17 pi over 6. Again, that's larger than 2 pi. So let's subtract again. Now we're going to say 17 pi over 6 minus 12 pi over 6. And that gives us 5 pi over 6. Now, 5 pi over 6 is something that we can work with. We know that 5 pi over 6 is in quadrant 2. Thankfully, do you see that we've already even found the terminal point at 5 pi over 6? So the terminal point for 29 pi over 6 is the same as 5 pi over 6 because they land in the same location. Does everybody see that? So the terminal point is going to be same thing as here. Negative root 3 over 2, comma, 1/2 be the terminal point for 29 pi over 6 because that is lands in the exact same place that 5 pi over 6 lands. Last thing I want to talk about is a couple of questions in the beginning of your homework you'll see are a little bit different, and I want to give you an idea of what they're asking. One question asks, where is the point root 3 over 3, comma, root 2 over root 3 on the unit circle? If you're ever asked where something is on the unit circle, or actually the question should be, is the point on the unit circle? And then we're going to ask where it is. So to figure out whether or not a point is on the unit circle, you want to use the general equation for the unit circle, which is x squared plus y squared equals 1. That's the general equation for the unit circle. So if you're ever curious as to whether or not a point is on the unit circle, you just plug that point in to that equation. So we say root 3 over 3 squared plus root 2 over root 3 squared equals 1. Simplify and see if it works out. It's going to be 3 over 9 plus 2 over 3 equals 1. So 3 over 9 plus 6 over 9. And that 3 over 9 plus 6 over 9 equals 1, which is equal to 1. So yes, it is on the unit circle. Now, to answer the question, where on the unit circle? We look at it. It's the x value is positive and the y value is positive. So it must be in quadrant 1. So it's a real simple question, but if you haven't been walked through it, sometimes it can be a little bit more difficult. The only other question I'm going to point out is a question. Okay, the last question we're going to talk about is a question like this, where it says the y-coordinate of P is negative 1/3 and P is in quadrant 4. Find the x-coordinate. So again, we're going to use our trusty little formula. We know that y is negative 1/3, so we say x squared plus negative 1/3 squared equals 1. So x squared plus 1/9 equals 1. X squared equals 1 minus 1/9. So x squared equals 9/9 minus 1/9. So x squared equals 8/9. We take the square root of both sides and we get x equals plus or minus root 8 over 3. And hopefully you all know that root 8 reduces to plus or minus 2 root 2 over 3. So now our question is, do we find positive, is it positive 2 root 2 over 3 or negative 2 root 2 over 3? That's where the quadrant comes into play. Because it's in quadrant 4, the x value is positive, the y value is negative. And so do you see that that translates? Do you see our y coordinate of P is indeed negative 1/3? So because of that, we know that y is negative 1/3 and the x is going to be actually positive. So our x-coordinate is going to be positive 2 root 2 over 3. So our ordered pair here would be 2 root 2 over 3, comma, negative 1/3. Okay, and that is the end of the section 5.1. I hope this made a little bit of sense to you. I'm still getting used to working with this online lesson thing, so hopefully as I get more and more used to it and you get more and more used to it, please let me know what makes sense and what doesn't to you, and we can try to improve on this. Okay, today we are going to start Chapter 5. Chapter 5 is where we're